Hello, my AP Statistics students, Mr. Luya here, and I wanted to go ahead and go over yet another FRQ where we have to identify the correct inference method and then follow the four-step process after that. And the 2014 exam is just perfect for that. So if I look at number 5 on the 2014 AP exam, it says, a researcher conducted a study to investigate whether local car dealers tend to charge women more than men for the same car model. Using information from the county tax collector's records, the researcher randomly selected one man and one woman from among everyone who had purchased the same model of an identically equipped car from the same dealer. The process was repeated for a total of 8 randomly selected car models. The purchase prices and the differences, woman minus man, are shown in the table below. Summary statistics are also shown. So what you see here is you see, like they look at, and I'm going to start kind of using my language carefully here. They look at a pair of women and men and compare their prices, another different pair of a woman and a man, and see what they were charged for that car model. Another pair of, I think you're getting the hint here, that we're basically looking at pairs. And if you look at the design of what this study is, like this observational study, it's kind of like a matched pairs design. Right? Where they look at different pairs and compare within each one. And then a lot of times a big hint, right? And that's not to say that it's always going to work out this way, but a big hint to know that you're doing a pair t-test is they usually give you a list of differences. Sometimes you have to make this list yourself, but again, it varies per question. Just make sure you're on the lookout for that. So they gave you a list of differences. They even gave you some mean and standard deviation of each individual group, the men and the women, and of the differences. And look at that. They were even nice enough to provide you with dot plots instead of you having to create your own box plot. But anyways, nonetheless, I think this is pretty indicative that we are going to be doing a paired t-test. Right? We're dealing with definitely a T because we're dealing with quantitative variables, price of the car. So let's just move on with our null and alternative hypothesis. So our null hypothesis and alternative hypothesis, it's always going to be the same for the null hypothesis. Whenever you're doing a pair t-test and you're trying to compare the differences within each pair that you're looking at, we're going to do mu diff, right? We're doing we're trying to compare the difference between the price of the women versus the men, or the price that the women were charged for the car than men were charged for the car. And the null hypothesis is always going to say, well, there is no difference. The difference is going to be equal to 0. But then over here for the alternative hypothesis, we're saying that the difference, what are they saying? They want to know if women pay more than men in the county for the same car model. Now, you can write this one of two ways. You can either say less than 0 or greater than 0. It really depends on which one you're subtracting first. I'm pretty sure, if you look right here, they went ahead in the problem. They said that all of these numbers that they calculated was that they did the women minus the man. So if in fact the women paid more than the man, or the woman paid more than the man, then the difference should be greater than 0. That's what we suspect. So that's what we're going to put as our mu difference. So the mu difference is greater than 0. All right? And it's never just good enough to just state the hypotheses like that. You got to define what that means. And in this definition, it's extremely crucial that, of course, you use your words true to let them know that you're talking about the population that we're trying to find. And obviously the mean difference, that's the other part. But you also want to specify if this difference is talking about the women minus the men or the men minus the women. Okay, it's that you will not get full credit on this part of the question if you do not specify that. So let me go ahead and say define that. So where mu diff is equal to the true mean difference, and let's say in purchase price. And this would be a really good spot to put that in there. Women minus men. Right? For the same car model. At the same dealer. Okay? Let's also not forget that we're going to be using alpha 0.05, and there you go. We have our full credit. Oh, I hope that didn't get interrupted, and my phone just has a little low battery. But anyways, so after that, we should get full credit for that portion of the problem. Step number 2, the plan portion. We're going to go ahead and identify our inference method. We already established this, right? Our inference method is going to be a paired t-test. Okay, then our conditions, we got to make sure that we establish whether or not this was random. So they pretty much said it in the problem. They said that the researcher, let's see what they said. They say the researcher randomly selected one man and one woman from among everyone who had. So that's pretty much good enough for me. So I'm just going to say researcher. And again, do not put random, check. That's not good enough. The researcher randomly selected. Instead of writing, I'm going to say less words. I'm going to practice writing more concisely. So randomly selected the subjects from the tax collector's records. I think there's an apostrophe there. Okay, perfect. So let me get this sheet of paper to kind of continue down here. So then we also want to get a few more. I like to have some cushion when I'm writing. So we look right here, and the next thing we got to make sure is that they are independent. All right. Well, they did say that these are samples. And, you know, as far as independence, we're just going to go ahead and check the 10% condition. So since we got sample of like cars for man and women, I'm just going to think about the population of all car, let's say all car, let me say car models sold in this county. All right. I'm not going to be too picky about like, you know, the population for this specific problem. Like maybe if the phrasing you used was that all cars of the same model purchased by the different genders or something like that. I'm just going to keep it a little bit more brief and say all car models sold in this county. In many other problems, it's a lot easier to decide what it is that you're measuring compared to 10 times the population size. So I'm going to say 10 times 8, which is greater than 80, so I think we're good there. And then for the normal condition, well, the problem is our sample size is equal to 8, so that is less than 30, right? However, if you do look, they did go ahead and already plot for you. Now, some of you probably are quickly typing this into your calculator and coming up with your list and then drawing the box plot. But if they already gave you a graphical display of the data, you can just go ahead and use that, and a dot plot is perfect for that. And ultimately what we're looking for, we're not looking to see if this is normal. This is obviously not a bell-shaped curve, right? But what we're ultimately looking for is that there is no heavy skewness or outliers. And based off of this dot plot, I think that's pretty safe to assume. So I'm just going to go ahead and continue on over here and say, but there is no heavy skewness or outliers in the dot plot of sample price differences. Sample price differences. So as long as you identify that the dot plot does not have any strong heavy skewness or outliers, we're good to go. All right, so that wasn't too bad for the conditions. Then finally, we're going to go ahead and do our do. So it's going to be using, and again, whenever you're doing a paired t-test, we're really only looking at one list of values here. We're not comparing the two. So we're not doing a two sample t-test here. We are just going to be using, or we're just going to be doing the same calculations as if this was a one population. So using t-test from the calculator. All right, so let me see. Let me go ahead and put that in here. Did I already do this one? No, I have to go ahead and type them in. So let's go ahead and put these differences on there. So we have 520, negative 100, 900. I should have already put this list in there to make this video a little shorter, but whatever. 200, negative 10, 1,200, 1,300, 670. I get the feeling the conclusion is that women do pay more, which is shameful. All right, so we're going to do tests, the t-test. We're saying that we're going to use data because we put all of our stuff in lists. So there is no difference. We're using list 1 frequency, and we wanted to test that it was greater than 0 for our, was it greater? Yeah, greater than 0 for our alternative. And then we calculate, and there we go. So we have t equals 3.118. I'll just use that. So let's see. T is equal to 3.118, and P is equal to 0.008. So P is equal to 0.008. And there you have it. So we have our P value. What alpha did we use? 0.05? Yeah. Okay, so since, and really it doesn't even matter what alpha level, even if it was an alpha of 0.01, this would still be lower than that. So since P is equal to 0.008, which is less than alpha is equal to 0.05, we reject HO. All right. So there is convincing evidence. So there's either convincing evidence or not convincing evidence. In this case, if we reject HO, that means there is convincing evidence for HA. So there's convincing evidence that, and kind of like if you saw the other video before this one, the one from 2015, you'll remember that usually there's always a word, so a phrase after that. Just copy and paste the problem and you get your full credit. That on average, because isn't that what the alternative hypothesis is pretty much stating? So that's all I'm going to say. That on average, right, women pay more than men in the county for the same car model. So yes, statistics can be extremely helpful here, especially whenever you're trying to do like a case study, or even if you're just writing an argumentative paper for any, like maybe an English class, or if you're trying to debate somebody. If you show them through statistics that, it's statistically significant, or there's enough statistical evidence to show something, then you can really make an argument for anything you want to, okay? And that's all done with hypothesis testing, and that's how people make a lot of claims. That's how people, get by with a lot of arguments in court or anything like that. So some very valuable stuff that you learned about in this class. So either way, I'm going to let it go there. Hopefully that was helpful. Hopefully you get your full credit on the AP exam for the 4-step process, and I'll let it go. If you have any questions, let me know, and I'll see you guys in the next video.